Welcome back to the course C# Advanced Language Features. I'm Philip Ekberg, and now it's time to look at a convenient way of defining a type to group a subset of properties or values. This language feature is known as anonymous types. Another way of looking at the anonymous type is that it's a temporary class used in the current method. The intent is never to return the anonymous type outside of the current method. There are ways to work around that, but we'll discuss the drawbacks of this later in the module. There are some good use cases for anonymous types. For example, say that you have a collection of data where you first want to apply a filter, then order, and finally get a new, less complex representation with only a subset of the properties. This data is then automatically populated into a data grid in a UI application. You could create a new class for this, but that seems a little bit unnecessary, especially when there's a language feature that will make this easy for us. Let's look at how to create an anonymous type. You create an anonymous type using the new keyword, followed by the object initialization. This looks like if you are constructing an instance of a type with object initialization, but you forgot to put the type of the object that you are instantiating. When the compiler sees this, it will in fact generate a type for you. If you were to decompile this and look at the generated code using something like ILSpy, which is a program that lets you look at the code that was generated by the C# compiler, you can see that the compiler generates a completely new class. The class is generated using a special name. You can see that the anonymous type that is generated overrides a few methods. For example, it overrides equals. Let's get back to that in just a moment. An anonymous type without any properties and values doesn't make much sense. To add some properties to the type, you simply use it like an object initialization. This is by first specifying the property name and then assigning its value. The compiler will figure out the type of the property by looking at what you assign to it. If you had two properties, which were both set to integers, the generated class will have a strongly typed property. Since C# is a strongly typed programming language, it makes sense that it generates this class. Looking at the decompiled code again, this will now have a little bit more code generated. Before looking at the body of the class that was generated, notice that the name of the class was also changed into something that represents what this anonymous type contains. The generated class has two backing fields for the properties that we declared. These are going to be read-only, meaning they can only be set when the anonymous type is instantiated. If you want to change the values, you cannot do so without creating a new instance. Looking further at what was generated, the override of equals performs a value-based equality. If you create two instances that both match the same signature used by an anonymous type, the compiler will be smart enough to use the same type for both instances. When the method equals is called, it will then perform an equality check on all the properties. Notice how it does not overload the equality operators. This means if you perform a normal equality check, this would yield false, while a call to equals would be true. This is because the equality operators check the reference equality, while equals look at the properties. The compiler is also smart enough to figure out the appropriate property names. You don't have to explicitly set the property names. You'll see that this is truly useful, especially when used together with a link. Not having to repeat yourself, and instead having the compiler do a little bit of work for you is great. An example of this could be if you construct a new anonymous type that contains only the order number and the total price. You could then access the properties on the anonymous type through the instance. As you can see, the compiler infers the names for the properties. It uses the same casing as the property or field that you are inferring the name from. This could, of course, be changed by explicitly declaring the name of the property on the anonymous type. It won't always be possible to infer the name of the property. If you call a method to retrieve a value that you want to store in one of the properties on the anonymous type, how would the compiler know which name to use for the property? Should it use the method name? Well, maybe that would have been a great idea. However, that's not the case. For method calls, you must explicitly declare the name for the property. It's completely fine to have some names inferred and some of them explicitly defined. For these situations where the compiler can infer the names, you could skip the explicit property names. The properties on the anonymous type can be of any type, just like you'd use with a normal class or struct. The anonymous type is only meant for properties. You cannot have methods on them. But as you've seen earlier in this course, you can use a delegate as any other reference type. This means if the anonymous type would have an action, func, or a delegate property, this would of course be possible to invoke like a method. But this isn't something that you'd normally want to do. The purpose of the anonymous type is to allow you to group some data in a local class without having to go through the trouble of creating a completely new class. It also gives you the benefit of being read-only. Now that you've learned what an anonymous type is and how it's constructed, let's look at a common use case for anonymous types, namely when working with collections of data using LINQ.